Morning YouTube. So a friend of mine made an observation that I had a few gadgets attached to my battery bank and wanted to know why I had these accessories and what they were for. And so the first thing is to say that the most important thing about a battery bank is to use them properly. I term it good battery behavior, which is detailed in another video I have about how to prolong your battery life. That batteries are used properly, not overdrained, not left in a state of undercharge and things like that. So once that is in place, on that basis, then one can sort of look at other accessories to promote better battery usage as well as prolonged battery life. So the accessories I have on my system are this, which is battery bus bar. That's the positive in that box, and in the second box that's the negative bus bar. I also have a desulfator, I have a battery equalizer, and downstairs in the kitchen I have a socket timer. I've also got a battery temperature sensor here, that blue cable, and that is attached to my charge controller. So essentially a battery bus bar. This is a heavy duty battery bus bar, and you can see it's rated for 500 amps, and essentially it's especially for people, well, particularly for people who have multiple strings where current passing through from one end to the other usually favors the batteries at one end compared to the batteries right in the middle. And over the course of years, this can cause inequality in your battery bank. So in order to solve that problem, what you do is that you use bus bars where every single string of batteries in a battery bank goes to a bus bar, and the cables connecting battery strings to the bus bar have to be of equal length, so that the distance that current has to travel from the bus bar to each string, and you can see 3 strings there coming out of the bus bar, so the distance the current has to travel is exactly the same. So in essence, you've got 4 batteries here linked together in series, and this is a string of batteries. That's the positive end, that's the negative end, and basically current flows out that way through the batteries within the string, and when you're recharging the batteries, current flows back that way, and it's all one string. So there is no issue here. Now 2 strings are hooked up together, so that is one string at the top, this is another string at the bottom, negatives linked in parallel, positives linked in parallel, positive that way, negative this way. So they are crucially diagonally opposite to each other. The positive is going out from that way, and the negative is going out from this end of the bottom string. So current goes out in that direction, and recharging comes in this direction. So there's a diagonality, which means that no particular string is at a disadvantage. We've got the positive end, well, we've got the negative end. Okay, so you can see that that diagonality takes care of most of the issues to do with inequality here. However, what if you've got 4 strings? In this case here, it becomes ridiculous, because current is going out this way, but say you are this battery here. Yeah, say you are this poor battery here, and the bank is being recharged. The current has to come through here before it gets to you there. Yeah, so you can see why some batteries that are far away from the terminals at the ends are slightly more undernourished than batteries at the ends, and this is what causes the inequality in the strings. Okay, so the solution to this is to basically use bus bar. This is the same battery bank. The crucial thing about the bus bars is that these cables here are equal in length, absolutely equal in length, the same with these ones, so that each string is the same distance from the bus bar. Yeah, each string is the same distance from this bus bar, and then from the bus bar you have a positive and you have a negative. So this is basically the principle behind using bus bars, to prevent inequality in your battery bank, particularly large battery banks we're talking about, because each string is now exactly the same distance from the bus. These three strings are for my three strings of 48 volts on the bus bar going in, and they're of equal length. And then from the bus bar you can then go to your inverter, charge controller, etc. So each string is equally far away from the bus bar, and that is essentially what it is. For the positive as well as the same for the negative. So that is why we use bus bars, to ensure that strings are equally nourished, equally fed, equidistant from the source of current. So yeah, I hope that's clear. So that's a battery bus bar. Obviously I have them securely locked away in these boxes here for safety reasons. And I'd like to emphasize again, bus bar or no bus bar, if I'm discharging my batteries to zero every day, I leave them on charge for days at an end, and I abuse my batteries, what will happen is I will die. So all this is nice to have, but essentially the basis is that you need to have good battery behavior. Alright then, YouTube, that's bus bars out.